Hey, welcome back. So we've already covered how to store data with variables and how programs make decisions using conditionals. But the real magic, the thing that makes programming so powerful, is doing things over and over again, automatically. And today we're going to master the one tool that makes all of that possible, the for loop. I mean, just think about the apps you use every single day. Do they process just one user or check one product? No way. They're handling thousands, sometimes millions of things at once. So how do they pull that off without the code becoming this gigantic, unreadable mess? Well, the answer is loops. They're literally the engine of automation in all software. So by the end of this, you're going to have a complete toolkit for handling repetition and Go. We'll kick things off with the basic for loop, check out its different flavors, see how you can control it, and then wrap it all up with a really powerful feature called range. All right, let's open up that toolbox. So what is a for loop at its core? It's really just a control statement that automates repetition. It's a simple but super powerful instruction. You're basically telling the program, hey, do this block of code over and over again until some condition is met. It saves you from writing the same code again and again. Just imagine you need to print every single number from 1 to 1,000,000. Could you write 1,000,000 separate print lines? I mean, technically, maybe, but it would be insane, right? A loop does that whole job in just a couple of lines. That's the kind of jump in efficiency we're talking about here. Okay, let's get into it. We're going to break down the classic three-part for loop. You are going to see this structure everywhere in Go, and for a really good reason, it's just so incredibly versatile. And here it is, the standard three-part for loop. Now, I know it might look a little intimidating at first glance, but trust me, each of these three sections, the one separated by the semicolons, has a very clear, very specific job. Let's take a look at each one. So here are the three essential parts. First up, you've got the start, or the initialization, I equals 0. This part only happens once, right at the very beginning. Next, you have the condition, I less than 5. This is the important part. It gets checked before every single time the loop runs. If it's true, we go again. If it's false, we stop. And finally, there's the after step, I++. This runs after the code inside the loop is done, getting everything ready for the next round. So what's the final output here? Well, the code prints 0, 1, 2, 3, and 4. But wait, why doesn't it print 5? Think about it. When I is 4, the loop runs, prints 4, and then I gets bumped up to 5. Then the program checks the condition again. Is 5 less than 5? Nope, that's false. So the loop just stops right there. See? That's the predictable, controlled automation you get with a for loop. Okay, so why is this so important? Let's say you're building an e-commerce site. Instead of having to manually call a function for every single order, you just use a loop. This exact same piece of code could process 5 orders or 5,000,000 orders. All you have to do is change the condition. That is what we mean by scalability. But what if you don't really need a counter? What if you just want to keep doing something until a specific thing happens? Well, this is where Go's for keyword gets really flexible. Let's check out some of the other ways you can use it. Now, if you're coming from another language, you might look at this and think, hey, that's a while loop. And you'd be right, conceptually. Go just simplifies things by using for everything. As long as that single condition, counter less than 3, is true, this loop is going to keep on running. It's absolutely perfect for things like, say, retrying a network connection a few times before it finally gives up. And what about things that need to run continuously? Like a web server that's always listening for requests? For that, you can create an infinite loop. You just use for with no condition at all. This thing will run forever and ever until the program is shut down or you specifically tell it to stop. Okay, infinite loops are cool, but you almost always need a way to control them, right? Go gives us 2 really powerful keywords for this, break and continue. Here's a good way to think about it. Break is like the big red emergency exit button. It gets you out completely. Continue is more like hitting the skip button on your music player. It just jumps to the next song. Imagine you're searching through a list of 1,000,000 users looking for one specific person. Once you find them, what's the point of searching through the other 999,999 people? It's a total waste of time and computer power. That's where break comes in. It lets you exit the loop the second you're done, which makes your code way, way more efficient. Now, continue is different. It doesn't kill the whole loop. It just says, hey, I'm done with this one particular step. Let's move on to the next one. So in this example, when I is equal to 2, continue tells the loop to just skip everything else and jump straight to the next cycle where I will be 3. And that's exactly why you don't see the number 2 in the final output. Okay, so far, we've just been looping over plain old numbers. But what about looping over actual data? Like a list of products or a slice of usernames. Well, for this, Go has a really elegant and powerful tool called the for-range loop. And this is what it looks like. When you use range on a collection, like this product slice here, it gives you 2 things back for every single item. First, you get the index, that's just its position, 0, 1, 2, and so on. And second, you get a copy of the actual value itself at that position. And as you can see, this lets you go through your data so cleanly. Just imagine this list of products came from a database, or maybe an API call. The for-range loop gives you a super simple, super readable way to process every single item that comes back. All right, before we wrap up, let's quickly touch on a few common mistakes. And trust me, every single developer makes these at some point. Knowing about them now is going to save you so much time debugging later. The biggest ones are getting your condition wrong by 1 and, accidentally creating a loop that never, ever stops. Take a close look at this code snippet. See what's missing? The post statement, that little I++, is gone. So since I is never changed, it's always going to be 0. That means the condition is 0 less than 5 will always be true. And boom, you've just created an infinite loop that can freeze up or even crash your whole program. Okay, let's tie this all together. Why did we just spend all this time talking about the for loop? Because it's not just another feature. It's a fundamental part of programming. Pretty much every scalable system you can think of is built on loops. Whether it's automating boring tasks, chewing through massive datasets, handling thousands of user requests, or just running business logic, loops are the engine that does all the heavy lifting. They are what lets a tiny bit of code do a huge amount of work. And there you have it. That's our deep dive into the Go for loop. You now get its structure, you know its different variations, like the condition-only loop, and the super useful for range, and you know how to control it. You've officially added a fundamental building block of software development to your personal toolkit. So I'll just leave you with this one question to think about. Now that you have this new power of automation, what's the very first repetitive task you can think of that you'd want to solve with a loop? Let that one sink in.